Alright, so in this video, we're again addressing a collection of vectors and see if they form a basis for a space. And in this case, we have three vectors in R3, and the claim is that they do not form a basis for R3. And so, as we've done before, our strategy is going to be to rephrase this in terms of vector properties, and then to use the matrix form of these vectors and its reduced row echelon form to see whether or not these properties hold or don't hold. So the claim is that these three vectors do not form a basis for R3. And so if we recall what that means either, let's again call the set S for simplicity's sake, S is not linearly independent, or S does not span R3. So just to briefly recap what it means to be a basis, the intuition we want to use is that to be a basis means that you are a good coordinate system for the space. And what it means to be a good coordinate system, one, is that you can reach everything in the space, i.e. spanning, and that there's only one way to reach everything in the space, i.e. linearly independent. If you don't span, you can't get everything in the space, and that doesn't make you a good coordinate. If you're not linearly independent, that means that I can get to a vector one or two ways, and that means that coordinates don't uniquely record points in the space, which is no good. So now that is our goal, is to show which one of these properties does not hold in this case. If in fact they don't hold, we need to write out the matrix form of our vectors. So let's pop in 3 minus 5 minus 5, 0, 3 minus 3, 3 minus 14, 4. And as usual, we want to find our reduced row echelon form of this matrix. So let's go ahead and ask ourselves what that is. And we can go ahead and enter in the various rows of our matrix. So 3, 0, 3 minus 5, 3 minus 14 for the second row, and for the last row it's going to be minus 5, minus 3, 4. And when I look at that and I take its reduced row echelon form, this is what I obtain. It's 1, 0, 0, 0, 1, 0, and then 1 minus 3, 0. And so let's take a moment and take stock of what this reduced row echelon form means. Well, first of all, if I were taking these first two vectors and trying to combine them to get this last vector, this, with the red dotted line, would be the augmented matrix form, and this would be the solution to that vector, the corresponding vector equation. And what we observe is that this vector equation has a valid solution. So what we can conclude is that since 3 minus 14, 4 can be written as a linear combination of the first two vectors, these vectors are not linearly independent. Right? And if we look back at our claim, which is that S is not linearly independent or S does not span R3, that by itself will be good enough to say that this is not a basis, because a basis needs to satisfy both of these criteria. So we could be done, but I'm just going to walk through spanning just so that we see how to do that as well. And so if we go back and recall what we've done with spanning sets previously in this section, what we note is that if we had an extra vector here and we're trying to solve the solution to some general V, and we took its reduced row echelon form, that we have the zero row here, and this zero row is telling us, hey, you could have something there, and then you would have that zero could be equal to that something, and that something could be non-zero. What that's saying is that you can't actually get to every single vector in the space because of this last row here. So we can also conclude, since the last row of the matrix has only zeros, these vectors do not span R3. So we've now shown in two different ways that these three vectors here do not span R3. They aren't linearly dependent. So we can finally conclude, thus, the original claim is true. S is not a basis. And remember, you could have done either one or the other. You don't have to point both of these things out to show that something's not a basis, but we did so for completeness sake and just to see how you would do so in one case or the other. All right, thank you very much. I'll see you in the next video.